Hello, everyone. Today we're going to talk a little deeper into voting theory. So I'm going to introduce this topic of weighted voting. So I kind of hinted at this the first lesson, but we're going to go into a little more detail now. So let's start with a few definitions. So in a weighted voting system, we have what are called the players. These are the voters in a weighted voting system. And we will use N to denote the number of players, and typically we label it P1, P2, meaning player 1, player 2, all the way up to player N. So if there's 5 players, all this is saying is we'd say P1, P2, P3, P4, P5. Okay? The weights, each player controls a certain amount of votes. This is called the weight of the player. We assume weight to be positive integers, which are positive whole numbers. And we denote W1, W2, Wn as the weight of each player, and we normally order them from most to least. So if you look at the end here, this is how we typically write a weighted voting system. So we have the list of weights of each player, and then we have this Q. So that Q is the definition under it. That's the quota. This is the minimum amount of votes needed to pass a motion and is denoted the letter Q. So the quota can range from a simple majority to 2/3 to unanimous. There's no rules for Q. It's just depending on the situation, Q could be really any number. So the idea is if you have a weighted voting system, the first number is going to tell you how many votes you need to pass, and then the numbers that come after are going to be the weights of each vote. So for example, let's say it's 5. That means you need 5 votes to pass. Let's say player 1 has 3 votes, player 2 has 2 votes, 3 has 2 votes, and let's say 1. So it looks something like this. So meaning there's 4 people, or 4 players, since we have 4 numbers here. One person's vote's worth 3, 2 people have votes of 2, and then one person would have a vote of 1. So 5 of those votes would be a win. Let's get into more detail. So, for example, in venture capitalism, if we have 4 partners, we'll call them P1, P2, P3, and P4, decide to start a new business venture. In order to raise the $200,000 needed for the startup, they issue 20 shares valued at $10,000. So to raise the $200,000, we have 20 shares at 10,000. 20 times 10,000 would give us the 200,000. And then this way, different players can buy different portions of the company. You might not be able to split it equally if one person has more money they're contributing, and then other people might have less. And that's normally how shares are going to work. So player 1 buys 8, player 2 buys 7, player 3 buys 3, and player 4 buys 2. Okay? So those are all the shares. And then share, you could really normally replace that word with vote. One share, one vote. Really, that's interchangeable. So if we need a 2/3 vote is needed, how many votes are needed? So pause this, think about it for a second. If I have 20 votes and we need a 2/3 vote, so if we do 20 times 2/3, we get about 13.3 something. So you can't have a partial vote. So 2/3, we round to the next number. So normally in rounding, you learn you round down, but in something with votes, you have to round up to the next whole number. Even if it was like 13.001, you probably would still round that up to 14. Okay? And then what is the notation used? Okay? So let's write this out. So 14 votes wins. Player 1 has 8, 2 has 7, 3, and 2. So that would be our voting system. So now we have to figure out the combinations that pass. So 8 plus 7 would give me 15. So if player 1 and player 2 votes, they would pass. So that also means 8 plus 7 plus 3 would pass. If everyone votes the same way, it would pass. So player 1 and 2, player 1, 2, and 3, player 1, 2, 3, and 4. If they all vote yes or all vote no, something would pass or fail. But let's focus on just pass. Okay. Let's see if player 1 says yes, but the other two players say yes as well, but player 2 says no. So no 7 here. So 8 and 3 make 11, 2 is 13. That would not pass. So if 1 and 2 don't agree, then something doesn't pass. So truly, that would mean if I had the 7, that wouldn't pass either. Right. So this raises some questions. If player 1 says no, it's over. Player 1 has a lot of the power, but player 1 and 2 have to vote together for it to pass. So these are our three combinations here. All right. So this is called anarchy in a weighted voting system. So we have the same partnership, same business idea, and now we have 10 votes needed to pass. So I want you to think about this. What problem could we run into here? So pause it, take a second, think, write down what you think. So an anarchy means we could have a tie. So we really could never say 10 because we run into this problem. 8 plus 2 is 10, and 7 plus 3 is 10. So we could have a tie. So it wouldn't be practical to pick this quota number to be 10, because what does that mean? It has the yes votes, but it also has the no votes. So when we pick a quota, we want to do it in a way that there can't be any ties. We don't want ties. Ties don't make any sense here, because then you need some tiebreaker somehow. So instead of 10 as your quota, the simple solution here would just be make it 11. So we always watch out for that in a weighted voting system. Okay, let's look at another situation here. So 4 college friends go into business together. 3 of the 4 invest 10,000, and the other is a little short and invests 9,000. If there are $1,000, so if each share are $1,000, how many shares does each friend have? If the quota is 30, what is the breakdown? And how much power does player 4 have? So pause this and let's answer those questions. So quota 30, and then we have 10, 10, 10, and 9. So I'm not going to answer this question, but I want you to. How much power does this person have here? What problem do we run into? So in a voting system, we have what is called a dictator. So in a dictatorship, in a voting system, one player has enough to carry a motion single-handedly. So a lot of times companies do this if someone says, like someone is the major owner of a company, but still has a team to help them out, but there is one person who really owns this company. Probably pretty rare, but it is possible. So this means that player 1 here has 12 shares. So if player 1 has 12 shares, then if they vote yes, it passes. If they vote no, it would fail because 5 plus 4 would be 9. So there's no way it could pass. So whatever player 2 and 3 do doesn't really matter. So player one would have complete control, and then we call that a dictator. So if one person can pass the motion, that's a dictatorship. More common, what you would see is what is called veto power. So we consider this weighted voting system, 12 votes to pass. The four players have 9, 5, 4, and 2 voting power. Can a vote pass without players 1's support? And thus player 1 cannot pass, sorry, answer that first. Can a vote pass without player 1's support? So to do that, we do 5 plus 4 plus 2, which is 9 plus 2 gives me 11. So no. So what this tells us is if player 1 says no, it doesn't pass. That's called a veto. However, if player 1 says yes, that doesn't mean it passes either. Player 1 would have to say yes, but it needs the support from some other people. So if player 1 and player 2, that would be good. And then player 1 and 3, sure. Player 1 and 4, that's 11. That doesn't work. So you need, in this case, support from 2 and 3. So veto means you have the power to say no. If you say no, it's over. But it doesn't give you enough power to pass something automatically. So this is probably more common in practice, that if someone is a major owner of a company and everyone else is splitting up a little of the shares, they'd have what is called veto power. Right. So let's introduce another type of power, which is called bonds-off power. So the US Senate has 100 members, and a simple majority of 51 votes is required to pass a bill. So in this made-up scenario, imagine the Senate is composed with 49 Republicans and 48 Democrats and 3 independents. So the voting system would be 51 would be the quota, 49, 48, and 3. So making a major assumption here that Republicans would all agree, vote the same way, Democrats would all agree, vote the same way, independents all agree and vote the same way, which in practicality probably isn't true, but let's make that major assumption. And then let's now talk about the 4 ways a bill could pass. So try and find those 4 combinations. I'll give you a second, so pause it. So obviously, if everyone says yes, something would pass. If just the Republicans and Democrats agree, it would pass. Or if the Republicans agree and the independents agree, it would pass. Or if the Democrats and independents agree, it would pass. Okay. So let's give a few more definitions here. And then we're still going to get back to this major definition here. All right, so we have what's a coalition. A coalition is any set of players that join forces and vote the same way. The coalition of all players is called the grand coalition, so if everyone's in agreement. The winning coalition is some coalitions have enough votes to win on their own. So if you had, let's say, 52 Republicans or 52 Democrats, that'd be a winning coalition, because if they said yes, it would pass. And the reason we use the Senate here is because it perfectly describes all of these vocabulary words. That's probably the most common example of having a coalition, even a winning coalition sometimes. But let's go to the next question. So in the Senate, what would the winning coalition be? So The winning coalition would be if the Republicans and Independents agree, or the Democrats and Independents agree. That would be a winning coalition. Or the off chance everyone agrees. That's almost like the trivial case. If everyone says yes, we oftentimes just ignore it because it'd be obvious. If everyone agrees on one thing, what are we voting on? Okay. Now let's define two more things. So this is where the bonds off power comes into play. We have what is called a critical player. A critical player is if a player decides not to vote, then the election would not be won. The critical count, for each player we count the number of times that player is a critical player. In the Senate, in general, who is likely to be a critical player? What do you think? So I'll let you think about this one. So I won't give you the answer on this one, but write this one down in your notes. What do we think? Who would be a critical player? If we have 3 players and someone doesn't decide to show up, is that enough for a bill not to pass? Okay, but now let's actually compute something. So if we want to compute bonds off power, we make a list of all possible winning coalitions. Within each coalition, we determine which players are critical players, and then we find the critical counts. We add them together to find the total critical count, and then we compute the bonds off power distribution, which is the critical count per player divided by the critical count total. So did I write this one out? Okay, so I have another example on the next slide. Let's write this one out though. Okay, so we talked about there are 4 combinations here. So let's write it as Republicans, Democrats, and Independents. So if everyone votes together and someone doesn't show up, it doesn't matter, something would pass. If the Republicans and Democrats agree and someone doesn't show up, they both become critical. They would both need to be, if one of them didn't show up, it wouldn't pass. And that'd be the same. So this is kind of a silly example because everything's going to be critical or not critical. So these were our combinations. If the Republicans show up, wouldn't pass. If the Independents didn't show up, it wouldn't pass. If the Democrats didn't show up, it wouldn't pass. If the Independents didn't show up, it wouldn't pass. So that's why this isn't the best example, but it still does show everything, because if you don't show up, it doesn't pass. So what we're going to do is we're going to do the critical count per player divided by the total, which everything here is going to be the same. So for the Democrats, they're underlined twice out of the 6 things underlined, and that's going to be true for everyone. So this is kind of a boring example. If we want, we can change this to 1/3. But all we're doing is counting the total numbers of things being outlined and then breaking it up by category. So Democrats underlined twice, Republicans underlined twice, and Independents underlined twice. Here's a little bit better of an example where the numbers aren't exactly the same. So let's consider 4, 3, 2, 1. Quotas 4, someone has a power of 3, someone has a power of 2, and someone has a power of 1. So this is player 1, this is player 2, and this is player 3. So the winning coalitions are all the combinations that would win. So there are 3 winning coalitions in this weighted voting systems. So if player 1 and 2 vote together, we'd get 5 votes. So 3 and 2 gives me 5. 1 and 3 with 4 votes would pass. And then if everyone agreed, that'd be 6 votes. Okay. So now let's consider if someone didn't show up, would they be critical? So in my first case, if we have player 1 and player 2, so I'm looking right here now. So if player 1 and 2 vote together and one of them decide not to show up, doesn't matter which one, you wouldn't have 4. So they're both critical, so we'd underline both of them. If player 1 and player 3, if one of them don't show up, it'd be critical because 2 and 1 would not be, 3 and 1 would not be enough to pass. And then lastly, this is where it differs here, is if everyone votes together, so if everyone agrees, and player 1 doesn't show up, player 2 and player 3 just have 3 votes. So that's not enough to hit 4, so it wouldn't pass. So player 1 is critical, so we underline player 1. However, if player 2 doesn't show up, or if player 3 doesn't show up, it's okay. 3 and 1 make 4, 3 and 2 make 5. So it's still bigger than 4. So here are our critical players from each one. The weight in the middle is just if you add those together, it shows it's a winning correlation. Coalition, sorry. And then these are the critical counts. We underlined player 1 3 times. So sometimes we'll label it B1 is 3, which just means Banzhaf power of player 1 is 3. Player 2 is underlined once, and player 3 was underlined once. So 3 plus 1 plus 1 is 5. So that means the total critical number, so all of my denominators here, will be 5. So we find that number by adding them all together. And then my numerators, 3, 1, and 1. So for Banzhaf power of player 1 is 3. We underline 3 times out of the 5 total. And then the other 2 we underline once out of the 5 total. So really all we're doing is finding the critical players. The numerator is how many times we underlined it. And then the denominator is just the total amount of times that we underlined anything. And then this step 5 here, we can stop here with the fractions. You can change them percent, but there's no need to. So I'm going to leave this one as an exercise, and I want you to try this in your notes. So I'll give some hints, but I want you to do this all in your notes. So consider the fictitious Boston Celtics draft system. The head coach has 4 votes, the GM has 3 votes, director of scouting has 2, assistant coach has 1. 6 votes is needed to draft a player. Okay. So we'd have 6, 4, 3, 2, and 1. Okay. So I want you to find the Banzhaf power distribution. So first we want to find all the winning coalitions. So I'll give you the easy one. If everyone says yes and agrees, that wins. So find the other ones. And then you're going to go back and underline everything now if that player is critical. So in this, I'll just do the first case. I want you to do all the other ones. So player 1 doesn't show up. 3 plus 2 plus 1 is 6. It would still pass. It's okay. If player 3 doesn't show up, it would pass. If player 2 doesn't show up, it would pass. Actually, everything's not critical here. So find the other combinations. And then once you find those combinations, you're going to find the power of each one. So we have 4 players. And you want to find the power for each one. So there should be fractions. Remember, the numerator is the times we underline the player, and then the bottom, the denominator, is the number of times we underlined in total. So every single one should have the same denominator. Numerator might change, should be different for each one, or some of them. And then the denominator will be the same, so just the total number of things underlined. Okay, so we're going to stop here for today. That will be our last lesson on voting. And then the next time we're going to move on to our graph theory section. So again, if you have any questions on anything, always feel free to send me an email and I am happy to help out. Have a great day, everyone.